So this video is still a chapter of square matrices, and now we introduce the concept of, or we define a diagonal matrix. So we pick a square matrix, let us say Dij, okay, and we say that this matrix is diagonal if all the non-diagonal entries are all zero. Okay, so usually, let me give you first an example. Let us say we have a matrix. Okay, let us say we have a 3 by 3 matrix. Okay, so the diagonal entries A11, A22 and A33, they are all non-zero, but the non-diagonal entries, they are all zero. So all the other entries, they are zero. Okay, a matrix like this is a 3 by 3, but a matrix like this is called a diagonal matrix. For instance, in a 2 by 2 diagonal matrix would be this one. So any matrix the diagonal entries should be non-zero and all the other entries should be zero, right? If that happens, we have a diagonal matrix. We can write diagonal matrix this way with a big D and then Dij, but the diagonal matrix, my favorite notation for diagonal matrix is this one. So we have D11, D22 till DNN. Okay. Now there is a theoretical question: if some of the entries are zero, is it still a diagonal matrix? Well, yes. Okay, if this entry, for instance, is zero, still a diagonal matrix. Okay, because the definition is some of the diagonal entries are non-zero and all the non-diagonal entries, they are all zero. Okay, then it is a diagonal matrix. Okay, let us see an example. We have this matrix A, that's diagonal 2 minus 3, 5, and matrix B, that's the diagonal 7, 4, 6. I think this is pretty obvious for you now that A diagonal 2 minus 3, 5 is this matrix A, 2, 0, 0, 0 minus 3, 0, 0, 0, 5, and B diagonal 7, 4, 6 is this matrix. Okay, let us say we want to find the product of A times B. So to find the product of A times B, you just have to multiply all these values. Okay, so that will be the diagonal. I'm going to pick this notation again of 2 times 7. Here it will be minus 3 times 4, and here will be 5 times 6. Oh, this is pretty obvious, right? This is a diagonal of 14 minus 12 and 30.